Okay, good afternoon. My presentation today will be focused on personalized ventilation, which is part of the PECS, and I will present you some field studies where we installed personalized ventilation and performed survey occupant response. But first, a little bit background why personalized ventilation is important because the present ventilation design, I believe, is inefficient. Clean and cool air is supplied from outlets, diffusers located on the ceiling, and by the time this clean air comes to the occupants, it collects pollution from building materials or from the occupants themselves, becomes warmer, and so occupants, in fact, do not breathe the clean air supply to the room. So there are also rather limited improvements of indoor air quality and reduction of energy if we want to achieve with this method. It is like this that increased ventilation is recommended in order to make the environment more healthy. However, this leads to increase of energy, where saving energy requires decrease of ventilation and then mediocre environment. So this is not a very promising way to perform good high quality of ventilation. So personalized ventilation is focused on each occupant. The diffusers, air supply diffuser, is located close to the breathing of the occupant. Each occupant has its own air supply diffuser, and the occupant or user may control the direction of the flow, may control the flow rate, means speed, local speed, and so temperature of the supply air, in some cases even relative humidity. In this way, it is as is shown in this figure, we may generate a clean zone at the workstation close to the diffuser, but then the occupant moving a little bit apart from the station, still we may have a comfort zone because of thermal comfort can be improved due to elevated velocity. And during the last 25 years, we have performed numerous experiments and developments in this system, a part of the very detailed physical measurements in coughing, breathing, thermal mannequins, particle image velocimeter, and so forth. We have done experiments with human subjects. More than 3,500 human subjects, participants have participated in several studies. And we have it documented that the people feel the air clean at the breathing zone, and they liked also individual control. They may adjust the preferred thermal environment, microenvironment at the workstation. They report better perceived air quality. We have measured improved health, increased productivity, and energy savings in some cases. So personalized ventilation can be implemented in practice either alone or combined with the background ventilation, background air distribution, such as mixing air distribution, displacement air distribution, underflow air distribution, and others. And itself, personalized ventilation may have different designs, as shown here, two of those, when the air is applied from the edge of the desk against the breathing zone, or from front, so against the breathing zone. And there are, of course, several other designs which I am not able to discuss today. But I will discuss more what we have, results we have obtained during field study. And the first one I'm going to present is in a building which is King and King, a building we call this is King and King company. This is architectural company, and the building is LEED Platinum office in Syracuse in United States. In this building, in a large open office, with 60 workstations. 38 workstations with personalized ventilation were installed. So that's about 53%. Before installation of personalized ventilation, employees were asked on special test desk to assess whether we'd like or not to have the personalized ventilation installed on their desk. So most of the experiments we collected were at room temperature of 23.5 degrees C. And you can see the office and also two of the workstations. We supply the air from a diffuser above the monitor. And on the picture to the right, we can see the desk with the PV supply diffuser and PV intake and displacement ventilation supply diffuser. I have to say that before this field study, the room was already ventilated with displacement ventilation supply diffuser. So we kind of benefited. We took of the supply displacement by the displacement ventilation and took it and bring it above the computer. But the user had possibility to control the direction and the flow rate of the supplied personalized air. And here is some of the results from the field study. First, with regard to thermal sensation, we compared the case when a response of users of personalized ventilation and non-users. As I already mentioned, approximately half of the 60 occupants were 33 had personalized ventilation and the remaining did not have personalized ventilation. The result shows that in general, no big difference with regard to the thermal sensation was observed. We used the ASHRAE thermal sensation scale, 7-point thermal sensation scale. The result with regard to the acceptability of thermal sensation, however, differed slightly. We in the favor of the users of personalized ventilation. In blue, they were larger percent of users reported totally acceptable environment compared to the case of non-users. With regard to the perceived acceptability of air quality shown in this figure, we use the scale which use is on the left side provided. We have from totally unacceptable to just unacceptable and just acceptable to totally acceptable. And the responses are shown here, and they clearly show that more users of personalized ventilation reported totally acceptable air quality compared to the non-users. The difference with regard to the air movement was also observed in the two cases. The scale we used or the questionnaire we used was based on the from totally unacceptable to just unacceptable, from just acceptable to totally acceptable air movement. And again, what we can see in the case of the totally acceptable, more PV users were reported totally acceptable air movement rather than non-users. So there are quite a few results. This study lasted for more than 6 months, but briefly the results I showed, and we may conclude that implementation of personalized ventilation showed potential for improving of perceived air quality, thermal comfort, acceptability, and thermal sensation, air quality, and air movement was higher among PV users compared to non-users. And the installation of personalized ventilation will be beneficial for providing preferred microenvironment at workstations and for increasing occupant satisfaction. Now I will continue with another field study, focus on a little bit different results. This is a study in a building in Copenhagen, in Denmark, we call it a Magnus building. This is again office with several work stations. And in this office, there was initially natural ventilation. Environment was quite not acceptable by the occupants. And it was decided to renovate this office from natural ventilation, and after renovation to built-in mechanical ventilation and personalized ventilation. And this is the building. It's an old building, but the office is shown with these two slides. More interesting is that during this process of rebuilding, we use two designs of personalized ventilation. One, which was developed at the Technical University of Denmark, and you can see it, we call it round movable panel. It generates a circular jet, rather gentle, very low, turbulent, and supplied did not disturb the eyes or face. And the another one was exhaust to PV design, which we already studied in the previous building King and King, which as I reported. So that the purpose was to see whether there is any difference in the design. I have to admit that before installing, selecting the PV, employees from the company came to our laboratory, our PV laboratory, and they experienced several designs of personalized ventilation. And of those designs, they selected these two. And I would like to say that some of the people selected this exhaust PV design, and others DTU. But questions why they have not selected the DTU design. They answered that they found it the best performing. However, they selected exhaust design because it fits better to the furniture, to the TV monitor of the personal computer. And some of the results of this study were, I'm showing only some of the results. The questions, is the PV in harmony with the surroundings at your workplace? We found that this is an important questions when people will use their personalized ventilation. And what we can see here is that people voted the system of exhauster, which is that one from below on the photo on the right side, because simply it was more ergonomic, was better, and it fitted better to the monitor and the rest. Although, as I already mentioned, the DTU design, which is provided more gentle airflow. It was also very interesting, however, the results which are shown to the question of how often do you adjust the air velocity, airflow. Here we can see a different result. We can see that much more often the air and the PV of exhauster was controlled compared to that of DTU. It was once adjusted, they use it for a long time without any need to be controlled the flow. So that is kind of interesting result, showing that the design of the personalized ventilation is very, very important. And I show you also results with regard to acceptability of the thermal sensation, acceptability of air quality, and acceptability of air movement provided in the case of natural ventilation. In the case of mechanical ventilation, if after we rebuilt the room and the ventilation of the room, and then mechanical ventilation combined with personalized ventilation. Almost the results were obtained almost at the same temperature. First, in the case of natural ventilation, then the mechanical ventilation was installed together with personalized ventilation. We studied mechanical ventilation alone, and then personalized ventilation in conjunction with mechanical ventilation. The results, as it can be seen in the case of mechanical ventilation combined with personalized ventilation, were superior. They're substantially better compared to the results, acceptability of these three responses compared to mechanical ventilation and natural ventilation. During this study, there was an online questionnaire, and the performance of the users was also monitored. However, due to limitation of the time today, I am not able to present these results. But the conclusions we made were that personalized ventilation in conjunctions with mechanical ventilation performed better than natural ventilation as well as mechanical ventilation alone. And it was interesting to find out that the design of personalized ventilation is important for its acceptance by the users and also the control. So long-term field studies are recommended to investigate the impact of the personalized ventilation on occupant health, comfort, and performance when it is implemented in office buildings. I have to say that our field studies lasted only for a month or so, but it is interesting to know in a longer period of time. So thank you very much. This ends my presentation.